I'd like to introduce Professor Wade Allison. Wade is one of the preeminent physicists in this country. He spent more than half a century, I think, teaching physics and natural sciences to UK leaders, or what have become UK leaders, and is for sure one of the leading voices when it comes to reason around our energy systems. So Wade, I'd like to just ask you, start of all, I mean, how did we get here? Not you and I, but how did we get here in this energy transition, and what are we facing? What's real here?
Well, I'd like to go back to start at the beginning, about 600,000 years ago, when suddenly we took a lead over all the other animals on the planet, probably starting with speech, and we learnt to work together and make teams of animals and teams of one another, hence from slavery came out of that. That was we learnt the technology of using the things we could see, like the wind and the water power and the vegetation that grew with the benefits of solar power. And that was the first revolution. And it made us top leaders on the planet. We sailed the seas, and we built great cities, and we learned to make metals and all the rest of it, and you know the story. But life was pretty miserable. Life expectation was awful. There were very few inhabitants on Earth by our current standards. But then, as we know, about 200 years ago, we suddenly discovered that with the reliability of fossil fuels and steam and so on, you could get all the energy you wanted 24/7, completely reliably, and suddenly all sorts of things became possible. For a start, it wasn't necessary to employ slaves anymore, because steam was much better than slaves. It wasn't a moral issue at all. It was the fact that we could have the luxury of doing it. So cities grew, and the population went up by a factor of 4, and life expectancy went up by a factor of 2. But now we are at the end of that revolution. We can no longer burn fossil fuels on which that was built, and we've got to start again. And so what we are now at a point which, as I say, we have been at twice before, 600,000 years ago and 200 years ago, and now is the new time. So I spent my life at Oxford teaching students and understanding about energy. And energy is really very simple. We know all about it. The latest and most exciting thing was to discover that what Einstein said about energy in 1915 in his general theory of relativity, generating gravitational waves, was absolutely correct. We discovered that in 2015. Science moves very slowly and very surely, and we are not going to learn much more about the science of energy in the next. Technology is another matter altogether. That's what mankind does with what we find, and that is full of thrills and spills. It's very exciting. It moves very quickly. Often it's utterly wrong, and people lose their shirts. And so I'm not a founder. Many of you are founders who are looking at that difficult side of it. But I'm doing the easy side and looking at what's possible. And if something's not possible, there's no point in trying to spend a lot of money doing it. So if we look at the science of energy, energy leaks away if you just leave it. Cups of coffee go cold. Boulders roll downhill. Energy doesn't sit around. There's only 3 sources of energy which are available to us. One is the fossil fuels, which are chemical carbon, which is left over from geological times and has become buried on the planet. The other is the effect of the sunshine and wind today, but that's not very reliable, as we have seen just recently. And then there's nuclear. And although you can't see it, it's very reliable. What's important, which Winston Churchill understood when he wrote in the Strand magazine as long ago as 1931, that nuclear is 1,000,000 times the energy of fossil fuels. So just to make it specific, the total amount of energy you need to drive your entire life could be provided by 1 kilogram of thorium or uranium. By contrast, in fossil fuels, you'd need 1,000 tons of coal will do the same thing, a trainload of coal for one person, all their energy needs of all kinds. Or in renewables, 10 million tons of water coming over a 100-meter high dam would do the same job. But it's the reliability that is really the problem. And as we have seen in the last couple of weeks, the reliability of the supply of energy can be a problem. Where have I got to?
I think that's a key point here, Wade. And you know, the interesting thing then is to consider this target date of 2050. I mean, we presented with this target date of 2050, and I keep wondering, you know, what happens in 2050? Does it all go poof, or does it continue past that point? And what do we need to do? Think about this. If we increase the population of the world as it is projected to be, West Africa is projected to grow to over 1 billion people. India is supposed to be getting up towards 1.3, 1.4 billion in the next few decades. We have an enormous demand for energy. We have, in fact, the lowest amounts of poverty in the world as more and more of the world moves into middle class and requires more energy. Are we really going to solve these energy problems, this energy transition, by using what you say is energy that doesn't really, or energy sources and technology that doesn't really give that to us? I mean, what, for example, do you think that, you know, an emerging nation would do? Are they going to go through the fossil fuel revolution that we went through? Or are they going to leapfrog it somehow? And how do you think they would do that?
Well, I think it's very important that they don't go for the fossil fuel thing, because then we will all suffer. What we've got to do is share with them. I think the COVID-19 experience has been a wonderful, if I don't mind using the word, a wonderful dry run of what a global threat looks like and how we've got to behave. Now, what we have seen in COVID-19 was, first of all, that the independent sector of people and businesses putting their heads together and applying science and coming up with vaccines. So that was, in fact, the easy bit. The bit that is more difficult is getting that vaccine out to the rest of the world, because the intellectual property of that vaccine is in a few small places. And most of the people in the world have no ownership or no right, and they don't have the money to buy the vaccine. So we have to somehow forego the restrictions of some of the intellectual property in order to get it out there in all our interests. And then finally, and not least, It's the problem of the anti-vaxxers, the people who don't want the vaccine. Now, you can put this all in the nuclear context. In the nuclear context, nuclear can provide the energy for all the world with a much higher population than we have now. But we've got to develop the technology, which we're doing, not ready yet to spin it out to the whole world, but we could mass produce small modular reactors the way the Americans built Liberty ships during the war, where they launched ships 2 or 3 a week. Mass production. Henry Ford comes to nuclear energy. So we could do that, but the world's not going to be able to pay for it. How are we going to do that? That's a big problem. And the next problem is we've got to educate people to love nuclear energy. Let me look right forward to 150, 200 years, because I agree with Michael that 2050 was only invented for as the biggest date that the politicians could swallow. It's nothing to do with the problem. Climate change is going to go on for hundreds of years, and we're going to need resilient sources of energy which can cope. We've got to learn to live with some pretty nasty, probably nasty incidents like of floods and fires and all the rest of it. But we can do it. Let me give an example of this. Some of you will know about vertical farming, that you can grow vegetables, particularly leafy vegetables, even now, and so on, inside. All you need is sources of energy and LED lights to shine on the vegetables and persuade them that it's daytime. And you don't have to worry about whether it is daytime, and you don't have to worry about whether you are at the North Pole or in the tropics. You've got you can do it at any time. Nuclear can provide all the energy, all the light, everything that goes into the vegetables. If we then eat the vegetables, we are, in fact, nuclear powered. We're not relying on the fluctuations of the seasons and the weather anymore. That's what we've got. We're a long way from that at the moment, but in a couple of 100 years' time, that is where I think we're going.
That's a key point, Wade, and I absolutely see where you're going with that. Now, the thing is that every conversation I have, whether it's in China or whether it's in Australia or in Brazil or the United States or here in Europe, and I talk about nuclear energy and I talk about what we can do with it, it's an extraordinary thing that wherever you go, people have this fear, this aversion, it's almost like it's become a bad word. And it's interesting to think about some of the facts around this. I mean, in this country, we've had nuclear power since 1956. That's 65 years now. You will remember when the first one got switched on. And we've not had a single incident. We've not had a single issue. We don't have an issue with waste. We don't have an issue with any radiological hazards. And another interesting part of this is that, a lot of that nuclear, the positive parts of nuclear is used in the medical field. And I was reading the other day that 9 million people a year are saved because of nuclear medicine, which is roughly the same amount of people that die from air pollution from fossil fuels. So there's kind of an ironic net zero right there. It's rather a horrible thing to say, but it's kind of there. But I mean, what is it? What is it that has gotten us to this point where this marvelous, clean, totally safe energy source, I mean, no one has been harmed by radiological hazards from a nuclear power station since 1986, when something went wrong in Ukraine in the dying days of the Soviet Empire. How do we get it? I mean, you've written books about this topic. You wrote a fantastic book called remind me of the title of Radiation and Reason. We've got copies of it here for you if you want it. But what happened, Wade? How did we get here with that?
One of the things about being a scientist or anything else is to do things, to work on things before things happen. This was written and published 9 months before Fukushima. And when Fukushima happens, I actually managed to get the BBC to publish something, which is extremely difficult because they run away from anything I say. But they did. And I said, this was 2 weeks, less than 2 weeks after the accident. I said, everybody should go home. Nobody's going to die. This is all in the mind. People did die. They died from being moved from old people, from being moved from their homes and moved away. Businesses went bust because of the restrictions and so on. It was all quite unnecessary. Nobody has died. Nobody's health has been affected by nuclear waste. The pioneer in all this, of course, was Mary Curie, whose name is very positive in most people's mind. She got 2 Nobel Prizes, nobody else has done it before, in physics and chemistry of nuclear power, and then got the reputation in medicine. Quite extraordinary. We've got to realize that the health, if we treated the health of our planet the way we treat the health, our own health, by using nuclear technology, we wouldn't have a problem.
That's a good point, Wade. And I think that's also where we have to think a little bit about the technological side of this, because the science and the nature of nuclear energy is well known. I mean, there's nothing about it really that we don't know these days. It's all there. It's been studied more than most things. In fact, the few accidents that have happened have been studied more than any accident in the whole world. And we've learned to do things in different ways. And one thing I find, and I find this fascinating, I'd like to hear your thoughts on this, is, we've got this technology that exists in nuclear today, notwithstanding the promise of fusion in the future and all these other wonderful things, but we've got this one technology. There's one nuclear technology that we're using, and it was designed back in the slide rule era. I mean, I'm sure you looked at
nothing wrong with slide rules. I was brought up on the slide rule.
But it is still being built today. For me, it's the equivalent of the Apollo program. Absolutely incredible that they could do this back in the 50s and 60s as they were building up the Apollo program. But now we've got SpaceX.
How much easier to do it now?
Yeah, exactly. And we can do new things. And in a sense, one of the things that seems to be emerging now is a popular opinion that's starting to look at nuclear in a different way, because it's looking at it not from giant, ugly-looking 70-year-old power stations. It's looking at it from the point of view of smaller machines that can't melt down, machines that can provide boundless amounts of energy for a very long time, and do that in interesting contexts, and starting to provide these sort of positive connotations that we need, not just power stations, but powering industrial assets, heavy transportation, heavy industry and processes. And this idea that we can do things at sea, I think this is the interesting part of this as well. It was mentioned earlier on that societies and big cities are largely on the coast, and the projection for the future is that we're going to be a coastal tribe. Now, the sea is really the limit here, isn't it, Wade? I mean, the things we can do at sea with this technology combined with water desalination, industrial processing, production of green hydrogen from seawater without polluting the air, and our heavy, sort of the backbone of international trade, shipping, can be powered by this in such a way that it doesn't pollute the environment. I mean, where do you see that going?
The ethos of the sea is interesting, because, I mean, this is something that you know much more about than I do, but the International Convention of Saving of Life at Sea, SOLAS, is built on the fact that in the inhospitable atmosphere or environment of the sea, everybody's got to look after everybody else. Safety at sea depends on everybody looking after everybody else, and you are obliged to go to peoples who need help. What we need is the safety of life on land. The globe is 71% ocean, and we've got a safety of life by cooperation there. We need to extend that to the land. And when we do that with relatively small reactors in each medium-sized city or in each county or thereabouts, then people will know where their power is coming from. They will have confidence in the technology. Some member of their family probably works there. Their children go there on school outings to see about it. It's not something hundreds of miles away, as we have in the present view of nuclear technology.
So you mean if it works at sea, it'll work on land, but not the
Why
other way
not?
around?
It's not true that the human spirit cannot survive at sea, and if it can survive at sea, it can certainly survive on land.
We absolutely know that. So here is something that I've thought a lot about as well, and I'd like to hear your views on this, is that the sort of the current thinking around nuclear, as we know, which really, as I was trying to say earlier on, is really just one technology. It's called the pressurized water reactor. It's an old-fashioned design that requires cooling water to make sure that it doesn't melt down. Now, we have technologies that really function in an opposite way from that. One of the technologies that we're developing with a company owned by Bill Gates in the United States is a molten salt reactor. A molten salt reactor is a liquid-fueled reactor with no pressure inside it, so it can't melt down. It doesn't have the ability to expel anything into the atmosphere. And also, it has that at the very heart of it. It has that sort of recycle and reuse that we really need for the sort of sustainable and resilient energy systems that we need. The fact that you can take that fuel out of a reactor that's been running for 50 years and reuse it in another one, and it goes from generation to generation to generation without producing that thing that people are afraid of, this nuclear waste, as they call it. But we have, in a sense, got to drive a wedge, haven't we, between a wedge in between what's conventional nuclear as it is today and these new advanced atomic technologies that are being developed in the United States, here in the UK, all over Europe. The Chinese are really making big moves towards this, and it's happening in the background. What do we do to bring this more into the fore? What do we do to bring venture capital investors, politicians, others to start looking at this and saying, actually, this is a solution, not a problem?
Well, as you said earlier, this is not a 30-year problem. This is a population problem for a number of generations. And the first thing we've got to do, or the biggest problem we have to face, is education. If people of my generation are too set in their ways and thinking about that nuclear is dangerous, the children and the grandchildren and today's students have got to need to learn why nuclear is completely safe, and to learn that it is something to love, as indeed in the medical field people do accept and welcome the work of Mary Curie. So there's a big, big education problem here, and this is something that in the first world we can do a great deal about. I mean, I've been out to Indonesia, for instance, and lectured out there to reassure them about, and I've been to Australia, but I wish I could go to more countries around the world to reassure people, particularly students, particularly talking in schools, which I do whenever I can.
I notice, actually, Wade, that when you have these conversations with people all over the world, there is a confusion between the difference between a nuclear weapon and a nuclear reactor, a nuclear energy system. And somebody showed me this interesting trick. They said, right, so imagine if I'm holding a gun in one hand and a teaspoon in the other. Now, if I hold up my teaspoon, you consider me a threat or no? And they said, no, I don't consider you a threat. It's made of the same material as my gun. Now, I hold up my gun, now I'm a threat. And it's the same sort of division that we have here with nuclear energy. People are not so sure about the difference between nuclear weapons and nuclear energy. And the fact is, nothing could be further from each other than those two. A nuclear reactor cannot have a nuclear explosion. It is physically impossible for that to happen.
But the evil, if I can use that word, is not in the reactor. The only thing that evil things that man has made is the story about nuclear, which is utterly wrong and frightening. In fact, if you want to find destruction, you go to somewhere like Syria or Iraq or Afghanistan, but they're not using nuclear weapons. They don't need them. They can be quite nasty enough to one another with conventional bombs and so on. So there's nothing, they don't need nuclear and they don't choose it wisely, but it wouldn't make things any different if they did. So I don't understand, or rather I don't agree with the present political view adopted by all governments, because it gives them power over people and over other nations about we do have nuclear weapons or we don't have nuclear weapons. What happened in Syria, really very recently, was absolutely ghastly, and it couldn't be worse.
And we have also this, I think, this perception that other people are afraid of nuclear, that somehow we hide behind other people's opinions. It's difficult, I think, for politicians to stand up and say, you know what, actually, I understand this and I believe that this is a good way forward, when they think that their electorate are against it. There was an interesting study a couple of years ago here in the UK, actually, which showed, they went and asked parliamentarians what they thought their constituencies thought about nuclear energy. And 80% of those parliamentarians asked thought that the constituency, the electorate, was anti-nuclear. And then they went and asked the electorate, and it was exactly the opposite. They thought that the 80% of the politicians were against it, and the debate wasn't there, the discussion wasn't there. It sounds to me, Wade, that we need to have a new kind of narrative here. We need to have a new kind of story behind this, right? The one that says to people, here is something that we can do to clean up the air, to clean up the water, to clean up the sewage, and to provide abundant energy in not just OECD nations, but across the world, that enables progress, that enables competitiveness, that enables this to happen with zero emissions, really as a standard, not as an aftermarket add-on, or at the price of the kind of things that we're seeing in the UK energy market now, or in the German energy market, shutting down nuclear reactors, installing weather-dependent energy technology, and then having to fire up again coal-fired power stations whilst prices go crazy. I mean, isn't this the proof that we need, that a new story is needed here?
Well, I think we've got to look at ourselves and talk about it. I mean, one of the problems is that people don't talk about nuclear. It's thought that we've been persuaded, or most people have been persuaded, that nuclear is somehow terribly difficult. It's above my educational pay grade. There's something hard about it. In fact, it's part of nature. It is no more sophisticated than coal and the burning of coal. It's just we've been actually using that for a few hundred more years You're taking, in one case, taking energy out of electrons when you burn coal. In a nuclear case, you're taking it out of the nucleus. But in fact, to follow on from Mikhail, we'd like to ask you as an audience who is unhappy about nuclear technology. Would you raise your hands? One? Only one? Two, three?
I wouldn't say unhappy, I feel uneducated, yeah.
You'd?
I'm uneducated.
Uneducated. Well, as I say, there's a solution to that, and I think we have to engage that.
You know something? It's a bell curve. You have pro-nuclear and anti-nuclear at the end of the bell curve, and pretty much everyone, no matter where in the world you go, it's agnostic, unsure. Please give me something that I can believe in. And I think this is what this is at. So let me give you a couple of examples of things that are happening around the world, and you guys should be aware of this. This is a ClimateTech conference. In the United States, the US government has put together something called the Advanced Reactor Demonstration Program, and it's a multi-billion-dollar program to reassert, if you like, leadership in new technologies. Not old nuclear technologies, not the sort of things that we've been playing around with for generations, but new ways of doing the things that we need to do. And there are a couple of interesting things inside there. One of them is the idea that you can use what's called a molten salt reactor. A molten salt reactor, like I was trying to explain earlier on, is you have a salt which melts at about 400 degrees centigrade, which means that if it's colder than that, it's solid. So it can't spill out anywhere. It's a salt that's chemically stable, and what you do with the nuclear fuel, this oxide that you mix into this salt, it actually creates the chain reaction in the salt, and it heats it up and keeps it liquid. That's why it's called a molten salt reactor. So you've got this fantastic liquid that's really quite hot at 650 to 700 degrees centigrade, which is great for producing hydrogen or industrial heat for difficult things. And it just circulates around inside this tiny little core. 700 megawatts is just under a meter in diameter in this core, where this fuel is moving around. It doesn't come out. You don't reprocess it. It just goes on and on and on. And you can do inline refueling, where you drop in a little bit more oxide, and the chemical doesn't change. Now, this is a small machine. This is something that's going to be about 3 by 4 by 6 meters. It can be made in a factory. You can have components arriving from around the world, and it's assembled, so you can do this again and again and again. Think of it like a big engine that you can put on a ship or next to a factory or in a town to power the tube system or the sewage or electrical charging stations. Or imagine if you had a giant, great offshore wind farm and you had this thing, this wire that brings that electricity on shore, but when the wind stops blowing, there's no electricity. So you need something there, some transformer that sits at that junction point and is able to load follow. So when there is lots of electricity coming from the wind farm, it powers down to where it needs to be, so you have this constant resilience, nice amount of electrons going into the grid. And that's something that we can't do with technology that we have today. We can't do this with a pressurized water reactor. We can't do this with technologies that they're building in Russia and America and China, et cetera, at the moment. But with these new technologies, we can do those things. And it opens up a whole world of possibilities, I think.
It's rather like the GMO technology, which are the details of which I am not familiar with. But in fact, we know that if you allow yourself to use the power of nature and redesign things, we'll learn how to do new things. Why should we run away from GMO technology? We'll have to be careful. Of course we'll have to be careful. But the safety of nuclear power over 65 years in this country and almost everywhere else, there's only 53, if I remember the numbers precisely, 53 people were, or was it 43?
39.
Died as a result of Chernobyl. Some people made some very frightening videos about it, but the animals that live in the evacuation zone around Chernobyl didn't watch the videos. They weren't evacuated, and they enjoyed the fact that the humans went away and left them to their own devices, and people now go to Chernobyl to visit the most fantastic wildlife park. And there are good Discovery Channel and BBC videos showing what wonderful things the wildlife is there doing there now. And we can really have a very large population on this planet and rewild the environment and not cover it with solar panels and windmills or indeed large coal-fired power stations. Nuclear has the smallest footprint and almost no impact on the environment. And that's where I think we should be going. It's the only place. It's not, some people say, oh, it's part of the energy mix. I think taking a 100-year view, it's not part of the energy mix. It is the energy source.
I think this is your chance to ask questions.
Yes.
And if you ever wanted to ask questions of one of the preeminent physicists of this country, now's your chance.
But don't worry about that.
We got one here. Stand up and shout.
Hi. This is a question about the previous
Could you say who you are and who
sorry.
you work for?
My name is Philip. I work for Accenture. So this is a question alluding to the point that you made at the beginning of your speech, which is you know what works and what doesn't work. So alluding back to...
No, I know what works in the natural science.
That's right. So building on that, so the three panelists we had, or four panelists had hydrogen, geothermal, and fusion as the technologies to back. If you had to back one of them, which one would you back?
Hydrogen, geothermal,
and fusion.
Well, geothermal is there. It's just a matter of getting it out. Fusion is hard because of the high temperatures and so on involved. Many technologies, in fact, are a question of materials and developing something that's going to last initially more than 5 minutes, and then more than a year, and then more than 20 years, because that is what investors need to know, that the technology has a good lifetime. And fission technology, we know, lasts 80 years and more. Fusion, we don't know yet. You spoke earlier about fusion, I think, didn't you? Yes. It was very, very interesting. And or geothermal, was it? Anyway, geothermal, of course, is there, and in many parts of the world, it works. It's very interesting to hear we might be able to get geothermal in other places in the world, like here. But that, of course, in truth, is coming from radioactive decay inside the Earth. But that's a technical, an academic point. So geothermal, yes. Fusion, not yet. I'm watching it. Hydrogen, did you say? Well, hydrogen isn't a source. Hydrogen's like electricity. It's a very good secondary vector for giving you the energy. It's got to come from somewhere. There is not a pile of hydrogen on this planet. There's a pile of carbon in the form of fossil fuels, but not a pile of hydrogen. So the hydrogen's got to come. If hydrogen's produced from nuclear, that is extremely useful. Whether it can be produced from renewables, the problem is that renewables don't provide enough energy. So that's a secondary source. Hydrogen is a secondary source.
Thanks, guys. Really, really interesting. My name's Charlie Mercer. I work for Codec, a lobbying firm for startups. Mikhail, you talked about molten salt reactors. What about thorium? Where does that play in the future of nuclear?
Thorium is just one of the fuels you can use in a reactor. It's kind of irrelevant.
Well, in terms of the fact that it can't be weaponized.
Oh, it absolutely can. Thorium isn't a fuel. Thorium is a feedstock for a fuel. Thorium is, so you have two types of nuclear fuel. You have that's fertile and that's fissile. Fissile fuel you can use in a reactor. And you usually have a combination of the two. A fertile fuel is one that can become a fissile fuel, and that's what thorium does. Thorium itself isn't a fuel. Thorium is something you have in the ground. If you dig up a cubic meter of soil in your garden, you'll find about 2 cubic centimeters of thorium. It's everywhere. It's one of the oldest materials in the world, but it isn't a fuel. Thorium transmutes into a fissile fuel, which absolutely has that potential. So that's a bit of an urban myth. Thorium, uranium, all the other ones, it's kind of, it doesn't really matter. It's the technology that you use it in that matters. What you put in it depends on where in the world you are. The Indians have plenty of thorium. They should be developing thorium reactors. In the UK, we don't have hardly any. We should be using something else. So that was it for today. Thank you very much. Wade, it's been a pleasure. We've run out of time.
Thank you.
Stephen, thank you for organizing, and thank you for your questions.